presenters, which is Rob and Nanaka. And I'll pass it on to, maybe let's start off with Rob. Can you give us a quick introduction about yourself, please?
Yeah, awesome. Thanks, Joe. I'm Rob Williams. I'm a solution architect based out of Sydney, Australia. I've been working with GitLab for, about 3 years now, a little over 3 years. As a solution architect, working with large enterprise and government customers across Asia, as well as most of Southeast Asia as well. I have a background as a software engineer, building and deploying very large workflow transformation applications, and through that process, fell in love with DevOps, which made it an easy jump to come over and work with GitLab to work with some customers on their cutting-edge DevSecOps strategies.
Awesome. Can you give us a little a quick fun fact about yourself, Rob?
Yeah, absolutely. Even though I do live in Australia, I've been playing baseball for 26 years now.
Wow. Is that like a semi-pro, professional level?
Amateur. I'm going to say amateur. It is a competition based, but everyone's just playing for fun.
No, I love it. Awesome. I'll also pass it on to Nanaka. If you can quickly please introduce yourself as well.
Yeah. Yes. Hello, I'm Nanaka from Japan. So I'm based in Japan and then working as an associate solutions architecture in this team. So thank you for all coming here today. And I am really excited to have time with you. So nice to meet you.
Nice. Nanaka, could you give us also a little fun fact about yourself as well?
Actually, so I'm really swimming when I was free. So I often go to the pool and then swim a lot, 1 kilometer, 2 kilometers. That is kind of my fun activity.
Whoa. We've got a professional baseballer and a professional swimmer in today's call. So any sports questions, feel free to put in the chat as well, or actually gets to the next good point. We do have some housekeepings we need to go through. So this workshop will be recorded. It will be shared at the end of the workshop. It will also be sent next Tuesday, and that's when you should receive it into your actual emails. We do have a break within this session as well. So we can, do we have what was the time for that break there, Rob or Nanaka? Do you know what time that is?
We don't have a particular time for it, probably around 60 to 65 minutes in.
Awesome. Okay. And also we do have a Q&A function. I know we have a chat function there, so feel free to use that for any comments or anything that you guys want to say. In terms of the actual questions, please use the Q&A function down below. There will be a large team of us at the back here who will be helping that. We've got a large, awesome GitLab team who will be answering your questions. So please use the Q&A and don't use the chat to help you with that as well. Throughout the actual webinar, there will be a poll as well. Please use the poll. We've got one. We can do an example one now as well. So right now, which of these fits your mood today? I'm based in Melbourne, so it is very, very cold. So I'm gonna choose rainy. But please use this poll throughout, and if you have any questions, use the Q&A as well. At the end of the actual webinar, there will be a survey. We would really appreciate your feedback to make this better for the next sessions as well. Please let us know how we can help better these webinars. And I think with that, we'll pass it on to Rob.
Awesome. Thanks very much, Johannes. That's a great intro. So today, we're going to be covering a lot of the sort of advanced CI/CD concepts, where we're going to go through a lot of the pipeline setup. We're going to go through artifacts and caching. If I skip to the right slide, we're going to go through the caching, some of the rules and ways that we can optimize the pipeline to run really efficiently. We're going to create some templates. We're going to look at the artifacts that those generate. And that's actually going to cover a lot of our security scanning as well. We're going to cover child pipelines. So this is going to be your multi-project pipelines and multiple pipeline setups for things like monolithic projects. Then that's where we're going to take that break that Joe mentioned. After that, we're going to get into the second half, and it's going to be a lot more complicated in that second half. What we've found when we've run similar workshops here is that a lot of the time, the attendants, the participants, like to do that part a little bit asynchronously. So if you do fall behind in that stage, don't worry. We have a bit in the future where we're going to talk about how the whole platform is going to be staying up for around 2 days. So you will be able to do this, complete this workshop afterwards. So if that part gets a bit complicated, feel free to just listen along, and then you can go through that part at the end, because that's where we're going to start to look at GitOps. We're going to look at how GitLab integrates with Kubernetes, and how we can enable things like our auto DevOps to completely automate the end-to-end pipeline process, going through the build, the test, and even the deployment. Then at the end, we're going to have a brief section where we're going to show you how you can transfer the work that you're doing throughout this workshop into a private namespace, so that you can continue to look at it even after the 2-day window goes through. And I believe we have a bit of a prize at the end to give away as well. So with that, we're going to go ahead and get started. How we're working today, right? We're all just we're part of this brand new startup company, Tanuki Racing. We've recently released our Tanuki Racing game, and our company is really looking for us to start implementing some automation, right? We're going to start to use GitLab for CI/CD so that we can learn about some of these different pipeline capabilities that are offered in GitLab. So before we really get into the workshop itself, we need to make sure everyone's set up. So we're going to make sure that everyone's set up on GitLab.com, and we're set up on Instruct, where we're going to deliver a lot of the hands-on instructions. Again, right, if you have any questions, feel free to make use of the Q&A functionality in Zoom. That's where we'll have our team who can answer those questions. So with that, how about we, as the Tanuki Racing engineers, we start to build our pipeline. So we can come over to Instruct and start the first stage. So I've got my test group open here. You should have yours open as well. And as well with the Instruct platform open. So what we can do is we can open up step 1, and we can start going through these various different steps for this. Just make that a bit bigger so that we can see it. So in a new browser window, what we want to do is open up. How about I make this a little bit bigger, just so that I can open up that page. We can open up that link in Instruct, so you should be able to see this within Instruct. And what we're going to do is click fork in the top right of the screen. So over in the top right, you're going to see this fork button. We're going to click that, and then that's going to take us to this page that's going to allow us to fork a new project. So if I come back here, right, we're going to come down to this project URL page, and we're going to select the existing Learn Labs group. So that's this group that we've got here on that page. So on the fork page, right, we've got workshop project here. Please don't change that name. It's going to be important for some of the automation that we're going to build out later. But under this project URL, we're going to select the namespace, and we should actually have the namespace that you've got here available. So what we can do is if we copy the ID at the end there, we can actually search for that as well, and that should just come up with just your namespace, the one that you have access to, and we can click on that. And so what that's going to do is when we create the fork of this project, it is actually going to appear within our test group here. So once we're done on that, we can click the fork project button. So that's, again, the blue button on the left-hand side of your screen. And we can fork that project, and it should be imported into your GitLab group. So we can see the forking is in progress. If I come over to my other window, I can maybe refresh. And there we go. I've successfully forked that project. Now I've got it open on my other screen here. And this can take up to a few minutes, especially since we have a few people forking all at the same time here. So once you have your project available, what we're going to do next is actually remove that fork relationship. So you should be sitting on this this workshop project page where we can see all of the different management options over here on the left, and then all of the files on the right-hand side here. So now what we've done is we've finished this step 1.1.4, and we can go on to 1.1.5. So on this home screen, right, the next thing we're going to do is remove that fork relationship. So on the left-hand navigational menu, we're going to go through, we're going to find settings. So settings is at the bottom here. We're going to go settings, and we're going to click on general. And you should be taken to a page that looks something like this. And we're going to scroll all the way down to advanced, and we're going to expand that advanced menu. So again, scrolling all the way to the bottom, we're going to find the remove fork relationship. So this is 1.1.6. And we're going to find that remove fork relationship. And we're going to click on the big red button here that says remove fork relationship. What we need to do here is we need to copy out the name of this project. So this is our workshop project. So we want to copy that, click into the text box and paste it, confirm that, and it should remove our fork relationship. Sorry, apparently my internet is breaking up. And what you'll see is a nice blue box at the top here saying that that fork relationship has actually been removed. So now if I come back to my project using the breadcrumbs or the project overview page, we just have our regular project here. We have no fork relationship, and that shouldn't have affected the source code at all. So with that, that's the first step in our first lab completed. And we can move on to step number 2. And this is going to be us creating this sort of starting pipeline. So the first thing that we want to do is click on project overview in the top left-hand side of the page, right? Just to make sure that we are on this home page again. And now that we have the project imported, let's take a look at the GitLab CI file. So we can just click on the file, but what we're going to do here is we're going to come over to the build menu on the left-hand side of the screen, and we're going to go into the GitLab pipeline editor. So opening that up, we can actually see all of the pipeline code that exists within our repository, and we can start to examine it. So looking at step number 2, we can actually see that we have 2 different stages defined, right? So build and test. We have a base image that's going to be used to run all of these jobs, and we have a couple of different jobs. So we have the build app job, right? That's going to run the yarn build commands in order to build our project. We've got the unit test job here. That's going to run the unit tests, right, defined using the Mocha package. And we've got a code quality job as well. One of the other things to note on this page is up at the top, we can actually see that this GitLab pipeline configuration is actually broken already. So the code quality job, it doesn't actually have a stage at the moment. So we have a few stages that are available, and basically we need to give this a valid stage. So we can see the valid stages up at the top of the file here, right? We've got build and test. Code quality, that's probably going to need to sit in test. So we can copy that test and remove this fake stage here because we don't have that stage defined, and make sure that code quality is going to sit within within that test stage. We can also use the validate tab in order to validate the pipeline configuration. This is going to break down a lot of the various different parts of the pipeline as we go through. And we can see that now we've successfully changed the stage of that code quality job. But this is actually coming up very green now. So we're in a good spot. And if we come back to the edit, right, and we can remember we changed this line 32 from fake stage to test. And after we've done that, we've confirmed that this is a valid pipeline configuration. So we can see that up at the top and as well through that validate tab. Now we were actually ready to commit this simple pipeline into the GitLab CI file. So what we can do is...
Sorry, Rob. Sorry, just to interrupt you there. Can we just confirm, we've just got a couple of questions here, just in regards to just to confirm if they're under the Learn Labs group, is that correct?
Yeah, they should be under GitLab Learn Labs.
Okay, awesome. Thank you.
So under GitLab Learn Labs, you should have a subgroup, right, that says My Test Group and then a little unique string there. So under the GitLab Learns group and under the My Test group, that's where we want to have this project.
Awesome. Thank you.
Awesome. So once we've fixed that that broken code quality job, we can actually commit those changes up. So we're ready to go. We can click the blue button at the bottom of the pipeline editor to commit those changes. As that pipeline runs, we should get, I'll just refresh my page here. Well, what we see at the top of the page now is that this is actually triggered to execute a pipeline, and we can come and view that pipeline as well. And we can see that the build app job, the code quality, and the unit test are all running successfully now that we've done that. Awesome. So once we've reached this point, we can go into click the next button. That's just going to load up the next challenge for us. But now that we've got that starting pipeline done, I'll just give it a little minute to make sure that everyone has completed that first stage before we continue on with a little bit more information.
Feel free to ask any questions as well throughout.
And as well, now that we've done this first lab, we're just having a little check-in to make sure that, I personally have a tendency to go a little bit too fast. So please let us know just how the pace is so far. We can see that for most people, it's just right. Maybe a couple that I'm going too fast for. So I can potentially slow down just a little bit. Also, just one thing to note here as well. Within the project itself, we have already created different branches that cover the various different parts of the pipeline. So if you do fall behind, right, you're sitting there and you're in that maybe the help where am I section, and you do get lost, you can always catch up again by looking at one of those branches, maybe merging it into the main branch so that you can continue on in that main branch, or by swapping to that branch and doing your work in that other branch. Awesome. So I'm going to continue on with the lab now, and where we're going to start to look at caching rules and failures. So the second lab as part of this workshop. So now that we've made this very simple pipeline, we go back to the team. We start to show them our new, very cool pipeline. And one of the questions that the team asks, and one of the questions that we were actually asking ourselves as well, is if we can actually make this pipeline faster and more resilient. So one of the things that we do see quite often is the ability to need to cache some of the parts of the job through the runners, right? So throughout the different jobs, through the runners and through S3 buckets. So that's the next thing that we want to start working on. The next piece of feedback from the team as we look to improve the different pipeline iterations. So when we define a cache within GitLab, the runners will take the content, and after the job has been executed, they'll store that in an S3 bucket. So what happens when we declare the cache is that the pipeline starts, the job runs, and once that job starts running, the first thing that happens is the before script gets executed, then the main script gets executed, and then the after script gets executed. So all three of those scripts happen before the cache starts to run. Then the cache runs, right? So the folders and files that we define as part of that cache, they get zipped up. and the file gets saved into a directory based on the runner's settings and the cache key. So now we've got that cache, it's stored in a remote bucket. Job B can then run, right? So the next job can run. And if the cache gets found, it gets extracted and loaded onto that runner by default before any of the other scripts start to get executed. So that allows us to store things like the dependencies of our code, increase that pipeline speed because we don't need to continually download various different content between the individual jobs. And it can even be done across various different branches. So if you have particular dependencies in one branch that you know are going to be needed in another, we can actually cache that in those buckets and propagate that across all of the branches. The most common use case here is definitely to store the code dependencies so that we can quickly and easily have that application running in every single job. Awesome. So now what we're going to do is we're going to start to talk about some of the rules that we have within GitLab jobs. So what we might also need to do is configure a way so that even if a job within the pipeline fails, then all the rest of the jobs are still able to be executed. So these are jobs that we're going to allow failure for. So allow failure true prevents a failing job from failing the entire pipeline. That job still gets marked as a failure, but all of the subsequent jobs are still allowed to run. And this includes things with the needs keyword as well. So if a job is allowed to fail, then once that job completes, then the jobs that rely on that through that needs keyword can actually execute even if it has failed. Some of the other rules that we have really affect the dynamicism of the pipeline and allow you to define when you want certain jobs to run. So you might have particular jobs that only run on certain branches, or you might have ones that only work on the failure of some of the jobs before them. So what we can do is use these rules syntax to affect how that pipeline gets created, so that we can do things like define different deployment jobs for different branches and things like that. So we have the if clause, the changes clause, and the exists clause. So changes and exists are looking at files within the repository, and the if clause uses CI variables in order to make that decision. We have a whole bunch of different operators. So is equal to, not equal to, approximately, not approximately, and an or, right? So all of these operators that are dictating that whole if clause. After we have the if clause, then we have those job attributes. So this is going to allow us to do things like delay jobs from starting. So using the start in function might allow us to say, okay, well, we now want to wait a few hours before we start to execute that job. We can also define the allow failure clause within these rules so that for particular variables, when those variables are set, then it allows failure, but other times it doesn't. And after we have the when attribute, then we can decide when we want that job to run, right? So this is going to be using functionality like always, right? So when we're on a particular branch, we always want this job to run, or when we're on a particular branch, we never want it to run. We can also use on success, on failure to decide, based on the success or failure of the previous jobs. We can decide to have a manual job, or using, again, right, that start in, we can use that when delayed in order to delay that job from running. So what this essentially means is that using these rules, we can decide when not to create jobs within a pipeline. So a job is not included in the pipeline if none of the rules that are defined for that job evaluate to true. Or if a rule evaluates to true, or we have that when never clause. So you can use that when never clause and chain them together in a few different rules so that we can decide when we want these jobs to run. We can also use when as a keyword to make particular jobs manual. So this is really useful, especially in sort of deployment scenarios where we have a particular environment we want to deploy to, and we want that to be executed through the pipeline, but we don't necessarily want it to happen automatically. So what we can do is we can define a job to have a manual activation, so that once the pipeline gets up to that job, then we execute that job by pressing that play button, rather than having it automatically execute at the end of when its turn comes up. So we can also use multiple rules chained together. So in this example on the screen, if the pipeline source is set to merge request event, or if that pipeline source is on a schedule, then this job will run, and otherwise it doesn't run. So in that way, we can set multiple conditions for the same variable. As I was saying before, we can also specify that we want particular jobs to be delayed. So this might be useful in a number of different scenarios where we still want that to automatically happen. We don't want it to be a manual event that has to be clicked on, but we still want to put in some lag time between the pipeline getting up to this job and that job actually executing. It might be for some asynchronous task. It might be, additional data needs to come in before we can execute the next stage. Or it might be, that we called an external script and we need to wait for that to run externally to the pipeline. So there's a number of different scenarios that might cause us to want to delay this. So we have that when clause to enable that. So when we have multiple rules, the default for when is on success. So if we want to change that and chain the rules together as independent rules, we can use that when clause to evaluate the various different scenarios. So the rules will execute in order from top to bottom from the definition until one evaluates to true. The pipeline will then use that rule and stops evaluating any further. So in this scenario on the screen, right, if we have a merge request event that's triggering the pipeline, then the pipeline, the job itself will not be included, and it actually would never execute the following rules. So it would never evaluate those rules. We can also use a number of different changes to various different files in order to define these jobs. So this job will, that's on the screen now, will actually become a manually triggered job when any of the files that are listed there have changes to them. And as well, we have that variable being set to string value. So using these two together, we can define a bit more granularly if we want that job to execute. So we've talked a little bit about variables so far and how we use them in rules. But within GitLab, there's a number of different ways that we can define those variables. So there's a number, starting at the bottom, there's a number of variables that come predefined from GitLab. These are things like your commit SHA, your branch name, environment names, and just general metadata from GitLab about the job itself. And these take the lowest precedence. So they will be set, but they're very easy to overwrite using one of the higher level variables. Moving one step up, we have the values that are defined in your GitLab CI YAML file. So using the variables block within the CI file, we can define certain variables. We can even overwrite the ones that we're getting from GitLab. Then we have values that get inherited from jobs in previous stages. So if you define a variable up higher in the first job, then in the last job, that value gets inherited from that job itself. So you can use the jobs to change variables within the pipeline and overwrite some of the values in YAML if that's required. Then we have the values that are configured for the project, group, or instance. So if you're setting a variable in the user interface of GitLab, that takes precedence over any of the values that are defined in the YAML files. And lastly, if we are doing a manual or an API triggered CI run, then the variables that we define when we trigger that will actually take precedence over all of the other variables. And so using this precedence, you can continually override the variables until we have the highest precedence for any particular variable. And then those are the ones that are used by the CI jobs in GitLab Runner. Awesome. So what we're going to do now is we're going to take a look back at our Instruct platform. We're on stage 2 now, so lab 2. So you can see in this progress window, if I can make my mouse bigger, we're up to stage 2, and we're going to do step 1 in lab 2. So what we saw when we made the pipeline last time is that after committing, it still took a little bit of time to run, right? It took about 2 minutes to run. We can see from this pipelines page. So while we build the next configuration, we really want to start caching some files. So maybe the node modules folder. So that doesn't have to continually be pulled. So what we can do is we want to add the code listed out here, right below the image definition in our pipeline editor. So coming to build pipeline editor, making sure you're on that page with that pipeline editor. We have the image definition here. We also have it at the job level, but we want to define this cache for the entire pipeline. So we're going to put it not at that job level, but instead up at this top level. And from Instruct, we can actually copy out the code that's listed there using that button, and then paste it into our pipeline file. So we can see here that we're creating a key for this based on the commit, and we're going to cache that node module. So on every single commit, it's going to have to pull this, but it's only going to have to pull it once, because every job from then on will be able to access that cache. So before we commit this, even though we have this cache available to us now, right? And once we do run this, that information will be available within those buckets for us to run the next time we run the pipeline. We're actually going to add a few more changes to this pipeline before we go ahead and commit it. So what we can do now is open up lab 2, so lab 2 step 2, and take a look at what we're going to do now. So the next step is that we're going to start adding some rules. So we're going to start with a basic rule on our unit test job. So looking over at the pipeline configuration, let's find the unit test job. And we can see it here, right? It's got image, it's got stage, it's got a couple of scripts, and it's set to run whenever we run the pipeline without requiring any other jobs. So what we want to do now is we want to add the rules definition here. So again, coming into Instruct, copying out that code using the button in the top right corner of the code block. We can come in after that needs keyword and paste that rule in. So let's take a look at this rule. So we've got the rules block where we're starting out with just one rule, and that's if the CI commit branch variable, so this is one of those predefined variables from GitLab, is equal to main. So this job we're saying should only be running on that main branch. If we're on a feature branch, we don't want that job to run. So while we're here, we're actually also going to add in the allow failure keyword rather into our code quality job. So we just want to be able to check and make sure what would happen if our code quality job failed. So again, we can copy the exit code here, right? So we want to put in over that script, making sure that the indentation is still correct. We want to put in -exit1. So this is going to make sure that the job is exiting with a non-zero exit code, which the GitLab runner will treat as a failed job. So now that we know that that job is going to fail, at the moment, this is actually going to fail the entire pipeline. So what we need to do now is change the rules for that job, and we can go on to step 4 and copy out the code here. And at the bottom of that job, from right underneath the needs keyword, we can paste in our rules block for this particular, for this job itself. So again, we're going to have on the CI commit branch, if we're on the main branch, then we actually want to allow failure. So what this means is if we're on that default, that main branch, then this job is actually allowed to fail. But if we're on any feature branches or other environment branches, this job will actually be required to complete successfully. So after that, in stage 2.2.5, we have the full YAML file listed out here, but I'm not going to go ahead and copy that because I've already copied it all out onto the screen. And what we can do is we can go ahead and commit changes again through this blue button in the bottom left-hand corner. So clicking on that commit changes, what we're going to see is that that our page reloads. It gets that new pipeline status. We can see that we have our pipeline starting to run again here. So last time we just used this view pipeline button, but we don't have to come through the CI pipeline editor in order to see the pipelines. We can just under build pipelines. We can actually see all of the pipelines that have run for our project. So yours should look something like this, right? We've got the two commits that we've made, right? The first one being when we fixed that CI file to begin with, and the second one adding in these CI rules. And we are on the main branch, so both of those jobs should be within this test stage. So we can go ahead and click on the hyperlink there that starts with that hash so that we can take a look at this pipeline. And we can see that code quality now, rather than having that nice green tick, actually has given us an exclamation point. So this means that the job has failed, but it's the GitLab has actually detected that this job is allowed to fail. So this is an expected failure. It's not a problem, and we're all good to go. So fantastic, right? That's exactly what we expected, right? These jobs are running on the main pipeline, and the code quality job is allowed to fail. So once you've reached this stage, we can go ahead and click next, and that's again just going to load up that next lab for us. Awesome. I don't see anyone shouting that they're too far behind right now. So I might just give it another 30 seconds before I continue on with the labs, just so that I can take a quick drink here. And I can see that that our esteemed moderators have put in another poll here. So what are your key initiatives in 2023? Especially from a DevSecOps perspective, right? Is your organization looking to maybe improve operational efficiency? Are we looking to improve our speed to market? So delivering better products faster? Are we looking specifically at security, right? Like, I know it's a big topic this year. We've got all these AI, generative AI functionalities pushing out more and more code through the pipeline. And as well, right, some very infamous hacks, especially here in Australia, last year? Or are you just looking to keep things as they are, keep the lights on, and look to improve down the line once we're a bit more stable? So let us know now in that poll. Awesome. It looks like there's quite a lot of people with quite a lot of different priorities. So most people, the majority of companies that the people here are working for, right? We're looking to increase the operational efficiency. We're looking to deliver better products faster, and we're looking to really reduce that security and compliance risk. So doing all of that at one time can be very difficult, right? It's often a trade-off between these two things, right? As we look to reduce security and compliance, operational efficiency becomes harder and harder to navigate. So that's where something like a DevSecOps platform can definitely come into play, so that we're making use of all of these three big ticket items at the same time. Awesome. So we're going to keep on moving now into templates and artifacts. So looking at how we can template various different projects and how we can generate reports based off those. So now back into Nuki Racing. We've now fixed up our pipeline. We're running very smoothly. It's very resilient. Even if code quality fails, we're starting to run. And we actually get some executives to come in and check on the progress that we're making. Now, they really want to make sure that we're taking full advantage of all of the features of GitLab. So GitLab, is an end-to-end tool. There's a lot of different functionality in there to, do things like reduce security and compliance risk. We've already increased our operational efficiency through automation, but looking at that security and compliance risk now, we want to take advantage of some of the features that GitLab has in that space. So what those execs have asked us to do is actually set up a demonstration of this in a pipeline. So we want to be making sure that we can automate these security scans and start to execute some of these and remediate some vulnerabilities that we find in that pipeline. So the most common security scanner that we have in GitLab is the SAST scanner. So we offer the SAST scanner as a CI template, and you can include that template in any pipeline. It's a language agnostic job, so that means it's going to detect what languages you are using and then add in the appropriate SAST scanner into your pipeline. So just by using that include keyword within the pipeline configuration, we can then link out to various different CI templates. This is one of the huge advantages of using a proper pipeline as code language for this pipeline definition. It gives us the flexibility to do things like in the rules blocks that we were looking at, and as well to really template out, take that object-oriented approach to these pipelines so that these jobs that are being used across multiple different tools, across multiple different projects, can be reused and inner sourced as we go on to improve that operational efficiency as we keep going through the development lifecycle. So these templates, right, they're really a collaboration tool. They're a way to share CI/CD capabilities with other teams inside your organization and to consume those capabilities that are being built by those other teams. It's really why GitLab ourselves, right, our engineering team, we provide a lot of the capabilities that we produce via templates. So that might be looking at our security scanning. It might be our end-to-end pipeline auto DevOps that we're going to look at a little bit later. But templates are not magical at all, right? The same way that we were building out pipeline files for Tanuki Racing already, that's how templates are built out, right? We could take that unit test job, turn it into a template, and just include it. So the templates are always executed into a pipeline, a CI/CD pipeline through that include statement inside the project's CI YAML. And template jobs are created within your pipeline based on the defined stage inside that template. And as well, right, of course, any of the rules that are defined within that YAML template itself. When we look at including various different CI templates, there's a couple of different ways that we can do it. So we can, include any of the ones that were offered from the GitLab engineering team. Right, and we can take a look at the repository of those later. There's a whole lot of different ones. We can just use the template keyword after the include inside that include block, and then list out the name of that CI file. If we want to include a file that's within the same group hierarchy from maybe another project or the project that we already have, then we can specify what the name of the project that CI YAML file is defined in, and then again list out the file location within that project under the file keyword. We can also even include different CI definitions from within the same project repository. So using that include local keyword, we're able to define multiple different pipeline files within one project and then execute them through one main GitLab CI file. Also, if you're looking to include something from outside of your own group hierarchy, you can use the remote reference as well for any publicly available project repository. So there's a whole lot of different ways we can do it, right? Whether you're part of like an open source development community or you're using the pipelines created by other members of your own team, right? Whether they're in the same project, the same group, or even different groups. There's lots of ways to include various different templates inside your own pipeline. Now, even though you've defined those jobs within a CI template, then they can still be extended and overridden by local jobs within the CI file that's making use of them. So one of the key ways to do this is through the variables that we've already looked at for CI rules. So a lot of our CI templates, including the SAST one, including the secret detection one, offer various different environment variables that can be used to change the behavior of those scanners based on the value that's being used. So with our security scanners, right, we include the options to set various different versions, to set the where you're actually storing the analyzers, the images for those analyzers, which image you want to make use of, including the various different versions, and if you even want to exclude particular paths from the from that scanner being executed. So using these variables is one of the key ways to modify some of the functionality within those pipelines. And as well, we can actually modify particular elements of the job from within a pipeline. So we can define a new job. So in this example, it would be use template. That's the job name. And then that's going to extend template, but it's going to overwrite the image and make sure that we use the Alpine image for that job template. So in order to understand the SAST jobs behavior, the default behavior, it's really best to look into the GitLab documentation. That's where all of our scanners are defined. It's also going to let you see what variables are there to make use of in order to customize the job to run to your specifications. You may also want to look at the SAST template itself. That's going to give you a little bit of insight into how those jobs are defined. It might serve as a good basis for implementing your own jobs down the line. So by default, SAST will use pattern matching to add in various different language scanners based on the languages used within your project. So our app is Node.js. So what we could do is just to tell the job that it only needs to use Node.js by excluding the rest. So we can do that using that SAST excluded analyzers, and using that variable, we can exclude a whole bunch of different analyzers and only use that Node.js one. Once we've run the SAST job, SAST will automatically generate artifacts, pipeline artifacts that contain all of the vulnerabilities that have been found by that SAST job. And those can be accessed a number of different ways. So either on that full pipelines page, we can download all of the various different compiled artifacts from all of the different jobs. You can download it on the specific SAST job itself, or from the page that's listing out all of the different jobs that have been run. Or we even have an artifact browser within individual jobs. So rather than clicking download, you might just click browse so that you can see all of the logs, all of the artifacts rather, for that job. So typically, artifacts will expire. So there's a couple of ways that we can specify those to be kept beyond the expiration, either including them as release evidence. We can also use that keep button on the job to manually set those artifacts not to expire. But just so that we're not continually building up a huge amount of artifacts, GitLab does specify that a lot of these artifacts will expire after a certain amount of time. Awesome. So that leads us into our next workshop part, lab number 3. So in this challenge, what we're going to do is we're going to start to add security testing into our existing pipeline. So what we want to do is make sure that we're still in that workshop project space. So we can look at our breadcrumbs up at the top here, right? And we're still in that workshop project. And what we want to do is we want to go back to that pipeline editor. So we're going to go build and then pipeline editor. So our execs asked us to add in SAST into our pipeline. So what we can do is if we come down to the bottom, it doesn't necessarily have to be at the bottom, but that's the recommended way of including some of these pipelines. And that's where we want to define this SAST template. So using instruct, we can copy out that code again, paste it into our CI file, and we're going to see this include template security /sast.gitlabci.yaml. So what we can do here, right, is, at the moment, we're just including a random CI file. We don't know anything about it, but GitLab's actually detected that there's an include statement here and actually lists out all of the included CI files and allows us to go and browse what that SAST job looks like. So we can see that this is actually a nested CI file. So the security.sast is just pointing us towards jobs.sast. So we can go ahead, look at that, and see the full definition for this CI variable, this CI job, rather. So you might want to take some time to look over this in the future. I'm not going to go too deeply into the actual execution of this, but one of the really important parts to check out is this variables section, right? This is going to give you insight into what you can make use of in terms of the variables to edit the functionality of that SAST job. So now that we have SAST installed, right, we've actually seen that there's a whole lot of variables. So we're going to set our own variable, and we're actually going to go a little bit beyond what our exec expects of us because we're overachievers. And we're actually going to copy out all of these other security jobs that GitLab offers as well, because we're very proficient with GitLab, and we know that we have more to offer to our organization. So now, copying out that code from instruct, we can highlight the whole include section, paste it in. That's going to give us our code quality, our dependency scanning, our SAST, our secret detection, and our container scanning. And it's also going to save the Docker file path in a variable to be used by other projects. Now, one thing to note here is that we actually are overriding that code quality job here with our exit job. We're not going to change that right now, but what we are going to change is that we want to edit some of our stages so that we can run all of these templates. So what we're going to do is we're going to copy out the stages here, highlight all of our stages, and paste that in. So now you should have stages, build, unit, test, and security, all four of those different stages. So what we can do now, right, we can see that we've got a whole lot of different templates over here on the left. Now that we've included that, what we can actually do is, it's already been validated that the syntax is correct, but we can actually see the full configuration. So once we expand all of those templates, we can actually come in and take a look at what that looks like. So you can see that by using these templates, we've actually added in a whole lot more functionality into our pipeline, and we're just having a look at what that looks like. So again, before we commit this, we're just going to add some inheritance rules into this CI pipeline. And what we're going to do here, right, is change what when and how that SAST job runs. So we can go ahead and copy that code from instruct. And what we want to do is come down to the base level of our CI file, paste it in. And what we can see here is that we're looking at that SAST job and we're overriding the stage. So we're moving into the security stage. By default, it'll sit in the test stage. And we're actually saying that it doesn't need any other job to run. So we're actually ignoring the stage definition and just using that as a logical grouping rather than a timing grouping. So with these two variables, even without defining a script directly within this CI file, our SAST job now can run as we expect it to. And we can confirm that through this full configuration screen. So before we commit this, again, we actually want to make sure that this is generating some different artifacts. So what we're going to do is we're going to go on to step 3, and we're going to change our build job. So we've got this build app job here. But what we're going to do is we're going to copy the code from instruct from step 3.3.1, and we're going to highlight the whole build app job and paste it in. And so it's got the same stage, it's got the same before script, the same script, and we're just making sure that the dist folder becomes an artifact for this pipeline. Now it's still going to expire within 1 hour, but now we're going to be able to have that as part of the evidence for this pipeline as we go through. Next, what we're going to do is we're going to go ahead and commit the changes. So again, down the big blue button in the bottom left corner, we're going to commit those changes up. The pipeline is going to start to run. And if it doesn't come up there, we're going to go to our pipeline screen and check it out. So immediately we can see that that the pipeline has a few more jobs, and that we've actually got 3 different stages now. So we've got build app that's started running already. We've got code quality that's already started to run. We've got the unit test section, and these are all running already. And then we've got in the security stage, we've actually got the Node.js scanner and the semgrep scanner. So those 2 scanners together are going to scan all of our code for some of these SaaS vulnerabilities. And once the build app job runs, then the container scanning, the dependency scanning, and the secret detection are going to start to run as well. So once we get that build app job completed, I'll just chuck a refresh in here. We can take a look at the actual logs of that job as well. Once this job completes, if my internet loads, once this job completes, it's actually going to have that artifact, and we can take a look at that artifact as well. Awesome. So I'm just taking a look at the chat here, right? And someone's asking me to show my includes again, just while we're waiting for that pipeline to run. And if we look at my pipeline here, right, I've got 5 different templates here. I've got code quality, I've got dependency scanning, I've got SAST, I've got secret detection, and I've got container scanning. You can find all of those in step 3.1.6. So you should be able to copy all of those out using the copy functionality in instruct, and just pasting it over your current include section, just to make sure you have all of those templates there. Awesome. So we can see from this pipelines page now that this build app job is actually completed. So what we can do now from this pipelines page even is start to download some of those artifacts. So we could take a look at our SAST report, right? And that's going to download a file into your local computer. And you can see it's a nice big long JSON file containing all of our vulnerabilities. So important to have this artifact. It's going to form a lot of the different reports that GitLab can do among security, and as well serve as the sort of the release evidence. Additionally, we've also got the build app archive, right? We can download that. It's a zip file, so I'm not going to open it right now, but you can feel free to open that up. It's going to contain that dist folder that we set as that artifact. We can go ahead and click next, and we can continue on. Oh, never mind. It's time for a break. So we're going to come back in 10 minutes. So it's here in Sydney, it's 2:18 at the moment. So we're going to take a quick break, 10 minutes, and we'll be back at 2:28 Sydney time. Awesome. Hope you're all enjoying the workshop so far, and we'll see you back here in 10 minutes.
Okay, so let's get started. So now we will go back to the presentation again. Okay, and now like we will, so you can pour again. So how are you feeling about the pace of the workshop so far? Like hopefully like Rob's presentation was really great. So like I'm trying not to make you tired so much. Okay, cool. So just right, I'm all good. Okay, most of people are all good. Cool. If you are in lost, like please like question in the Q&A chat spot. So please feel free to give the questions to the chat. Okay, cool. Then let's get started. So now next step, let's discuss child pipeline and the parent pipelines. So now imagine an incident happens after you demonstrate your pipeline, which has enabled the security team lets you know that they have been running their own pipelines with more scanners and wants you to integrate it with your pipeline. So you decided to the best way to do this is by setting up a child pipeline, a type of a downstream type, a child pipeline, which is a type of downstream pipeline. Okay, so let me explain about downstream pipelines. So a downstream pipeline is any GitLab CI CD pipeline triggered by another pipeline. So it runs independently and concurrently to the upstream pipeline that triggered it. So here is the pictures of a downstream pipeline. So first, a downstream pipeline enables multi-pipeline CI/CD setups and allows for different pipeline architectures. And last, like a child pipeline can be dependent on result or generate YAML files from the parents. So I will talk about the child pipeline flexibility. Cool. So like there are two types of downstream pipelines. So first one is like parent-child pipeline. So parent-child pipeline works in only one project and allows you to create sub-project connected to the parent pipeline by child pipeline. A parent configuration file can trigger all child configuration files. And then second one is like multi-project pipeline works across multiple projects. It can trigger the pipelines of other projects, but it doesn't have much control over the triggered pipeline. This one. So here is the script of a child pipeline. You can define specific rules in a child pipeline, and it allows you to get creative and make dynamic changes to the current result of your pipeline. Okay, so let's actually create a parent-child pipeline in your environment. Sorry. Oh, so yeah. As you can see, so your step one is preparing the child pipeline. So your security team got wind of all the security scanning you added to your pipeline and wants it to be added to a new pipeline that they have access to and can control which jobs are run. So to do this, we are going to create a child pipeline that we can link from our existing pipeline. In this case, we will just be adding the second pipeline to this project, but it could have been added in your separate project and being linked. So okay, so let's create the one like a child pipeline. Okay, so now like so Rob edit the pipeline. Rob edit YAML file with like pipeline editor, but like from now I will change the code with web ID. So you can click edit, and then you will find web IDE. And then, so like this. this is kind of looks similar to a VS Code, and then you can get all files here. So you can change the code in not only YAML file, but also like other files like index.html, like for example, like Docker file extra. So for now, well, we can like with ID, and then we will make a new folder. It's called which code? Sorry, which code? Create this pipeline. We will correct the web ID, and then I came here, and then create a new folder for its security pipeline. Okay, so security pipeline, and then under the security pipeline, we will make a new file. It's so which code, like security.GitLab CI.yaml. So I run in this period. Yes. So security.GitLab CI.yaml call. And then so this is the script for security, about the security section. So like we can copy here and paste this. So okay, cool. And then we will commit here. Okay, but before we commit this script, but as you can see, like we have the same script in the parent YAML file. So like remember, like it kind of duplicated the code, but like just so I want to compare to the script only with parent config file, and also with and child pipelines configure file. So like just I want to commit this one, even though it's duplicated. Cool. So let's see the pipeline here. Build pipelines. Because it's still working. So like when we are waiting for the pipelines to get ready, so let's remove the duplicated codes from parent YAML file. Okay, cool. So like as I said before, like here, so security part is duplicated. So we will remove this. And then the code cache is here. So that this part, the large this part will be removed. Okay. Oops. Oh, and then build. So we don't. This is also security part. So build up, and then okay, that's all. Cool. So and then like the last one, so we have to add the scripts to trigger the child pipeline. So we will add this extra security, like the new state called extra security, and then add this one, downstream security. So as you can see, cool. So the job's name is downstream security, and then it's linked to the file we made earlier. So security pipeline, the the folder's name is security pipeline, and then the YAML file name, which named security GitLab CI YAML. Okay. So, and then let's push this. Okay, so we can commit the message can be removed the duplicate code. Okay, I committed these changes to main branch. Echo and then go to pipelines, and then let's see the difference between the pipelines like I made earlier and then this time. Oh, so like it's still running. So okay, cool. And let's see it's here. So as you can see, so the pipeline we made it on step 1 is ready. So like that is kind of normal use. So in the Lob's presentation, so like just build job, test job, and security job. Like this security job, it's come from the parent YAML file. So just like we can see the same page. So now next another one. So just I made it. It can be. This is a pipeline. Like I just made it, and then as you can see, like you can see this is trigger job. So thanks to the trigger job, the child pipeline was running. But still not ready yet. Okay, so like as you can see, build job and test job is the same, but like in the test job, like some scanner is gone, and then also security job is gone, and then you can see the downstream security. You can see in the downstream security job, like you'll find the list of them, but still it's running. So we can go back. We can go back later. Okay, cool. So next, so while we are waiting, the pipeline is ready. Let's get started. Let's get started. Another topics here. So section 5, Kubernetes agent setup. Okay, so before we start, the rest of the workshop will focus on more complex aspects of GitLab CI/CD. So you have access to the system for 48 hours. So you will be able to practice and learn how to use these advanced systems yourselves. So after a very successful demo in front of the team, it's been decided to go all in with GitLab CI/CD. So as the ops engineer, you are first tasked with figuring out how to use the GitLab agent for Kubernetes to connect our connected Kubernetes cluster to GitLab projects so that the team can deploy applications using GitLab CI/CD. So, like, what is GitLab? So what is GitLab agent? What is GitLab agent for Kubernetes? The GitLab agent for Kubernetes creates bidirectional connections between the cluster and GitLab. So this is an active in-cluster component for connecting Kubernetes cluster to give GitLab safely to support cloud native deployment, management and monitoring, and other tasks. So this makes GitLab's agent for Kubernetes a great resource for GitLab ops support and CI ops support and security scans and IAC. So after I explained a bit I will show you how this can impact your GitOps and Git CI/CD workflow. Okay, so there are two types of receiving codes in a Kubernetes cluster. So push and pull. So in push-based GitOps, code starts with the CI system and proceeded through a series of encoded scripts to push changes to the Kubernetes cluster. Okay. This is the more traditional CI/CD approach, but it's not easy to operate because it typically works in only one direction. So from Git repo to GitLab repo to environment. So this is making it like impossible to separate the CI and CD. So the other system uses pull-based GitOps. Unlike push-based, pull-based GitOps can work in two directions. So not only can you pull your Git repo and container registry for changes, it can also compare the state of the cluster to the defined state in Git. So this means your Kubernetes cluster can use two-way comparison to detect and resolve configuration drift when your changes are made to the cluster manually or from other resources. This makes pull-based GitOps are more effective for Kubernetes environment. So these are the steps to set up Kubernetes agent. And now I'll demonstrate for you to see the process for yourselves. But before going to the Kubernetes setup, like I think this one is ready. Sorry, so like this is not going so. Oops, doesn't exist. Actually, I made it right here. So let me check again. So workshop projects. Oops, it didn't go. Sorry, it didn't make properly. Right, I will see what happens with this. So let me see the comment. Okay, sorry, so like I removed the corrective or like the earlier one is couldn't make it properly. So,
Hey, Nanaka.
sorry, yeah.
No, all good. I think that the only problem here is that you put that pipeline folder under the public folder rather than at the root of the repository. So if you go to the web IDE,
Yeah. So
you can-
here,
under
yeah,
the public folder.
and the public folder. Oh, sorry. Yeah, that was a mistake. Sorry, I had to make. So I had to move here. So like I will make the. I'm sorry about that. So I'll just read them. So just under the workshop project. Okay. So create. So execute the. I'm sorry about the security pipeline, and then on the security pipeline, I can create the YAML file that for child pipeline security GitLab CI YAML. So like this is the right? This pipeline now. So and then commit and get security. Here. Okay, now I got the new folders. It's which called security pipeline, and then under this folder, like I succeeded to making to make security GitLab CI. Okay, that works for the children pipeline. Cool. Okay, and then it works now, hopefully. Okay, so I'm sorry about that, and then it seems to taking time. Okay, so that one is the same pipeline. So the first one is just started just worked in the first. This one is like just in the parents YAML file. So like build job and test job and security job, and then hopefully this security job will replace the child pipeline to in this child, it will replace to the child pipeline. Yes, I'm sorry about that. Okay, now so like the build job is ready, and then like extra security pipeline which we made earlier, so that it's working now. So okay, so that was like that contains like code quality and dependency scanning and SAST and secret detections and container scanning. So that it's kind of template from it's kind of template GitLab provided. So like you can just get this from the GitLab's template. Okay, and then like so there are okay, so downstream security jobs is getting ready, almost getting ready, and then like so that the template works here as well. So and in the last workshop project that made it earlier is getting tricky. I'm sorry about that. So like as you can see, so our yes. Okay, so like okay, cool. And then downstream pipeline is also get ready. So this can be the child pipeline. And then you can click the details of them as well. Oh, so that is downstream pipeline. I'm very sorry about this. Okay, so now let's create let's set up Kubernetes cluster. So the next. Let's start this. So we now want to put in the Kubernetes cluster. So let's connect to the Kubernetes cluster. We will go to the web ID again, and then to fix the web ID again, and then to fix config.yaml file. So the config.yaml file located under the workshop agent folder. So here, and then now it's like passed to your group, and then you can get this code from here. So from environment to your group name. So from here to here. And then you can replace this one. You can replace with this one. So, and then as you can see, like ensure that you do not have trailing slash, as this will change your agent access from environment to your group name, from environment and your group name. And also, and you have different group names. So like just put here your group name. Okay, and next, so and then we can commit this. We can commit these changes. Press okay. Okay, so I committed this to main branch, and then I will see how it's going. Like, okay, so let's rework. So the step 2. So we will connect this agent to our GCP instance. So let's move to operate and Kubernetes clusters. So this one, and then we can this one. We then want to connect this agent to our GCP instance. So operate and Kubernetes cluster. From there and click connect cluster. So as we can see, operate and Kubernetes clusters. And as you can see, you don't have any clusters right now. So and connect the cluster, and you will find workshop agent here, and then register. So now you can find this Helm codes here, and then create Kubernetes, and next screen copy helm install command and copy it locally. So we can copy this and then paste this GCP shell that is the left side of your instructions page. So here, and you can paste this. Cool. And then now it says never connected, but like after this one is successfully updated. Okay, cool. And then now it's changed into connected status. Now this agent is running to your project. You can see this agent activity if you click the name of agent. This. Okay, so what happened is, okay, and then like activity, you can see the activities here, and also security. Like now you don't see anything, but like if you have any vulnerabilities in the cluster, you can, sorry, if you have any vulnerabilities in the agent, like you can find here as well. So next step 2, like integration cluster management. So navigate back to your path, and then like, so these sections we will move to the group level. So like you can link to group level from here. So that one, my test group, and then I only have one project right now. So and also like we can make a new project here. New project. And then create create from template. So, and then you will find the GitLab cluster management. You can scroll down and you will find GitLab cluster management, and we will use this template for now. And then so the name can be register files. So this this project can cluster management. Then click the create project. Okay, so like our change is this one. Just name project name, and then create project. Okay, it takes some time. Okay, cool. So you got another project here, and then let's move to web ID again. So from edit and then web ID. So now you can see different files here. And then now we will change the helm file. And then just uncomment line 19 here. And then uncomment it. So we only have this change. And next, and then we will commit this. Okay, I will commit. So this comment can be connected, and this comment is for installing an English port to the cluster. So we will install the English port. Commit to the cluster. And then we will see what happens. So this one, so we can go to the pipelines from here. Okay, so now diff job is running now. The pipeline is going through the file, and so diff job is recognizing the file we uncommented earlier, and sync job is going to actually deploy the application which will instantiate a pod in the cluster. So now diff job is get ready. So like we need to click the play button for sync job. Okay, cool. So while we are waiting the sync job get ready, let's check service in the Kubernetes cluster. So like, as you can see, there is a command here. Kubernetes get. So now sync job hasn't get ready yet. So like you only find the default service here. Default service here. So the default service can be Kubernetes, and also that it's like this is the namespace and then the name. So we can find the kube system namespace, and then the name of service is the default HTTP backend and kube DNS and metrics server. So, and then now like sync job is get ready, and then we can put the command again. And then now, as you can see, you got other two services now. So now the ingress got ready, and you find new spaces called GitLab managed apps, and also you get new two services. So, and then so we will focus on the ingress network controller now. So like we can copy, and then like only this port has the, oh no, it's not get ready. So okay, yeah, you can find external IP here. So like ingress net engine controller has external IP. So like we can copy this and then look for this. Okay, so like so I will go back to the navigate. I will go back to the system. Okay, cluster management. Okay, so now we can check what happens now. So now I got the external IP. So navigate back to the GitLab tab and go to the management team. So like we will go back to the group page again. And then so click management in the top. Oh, sorry. This page. So, and then like this time we will go to the settings and CI/CD. Settings and CI/CD. And then you can set the variable also. So the sections and use. So now we're the setting page. So after the variable will the product mask node there. So now we can add a variable here. So like I've already added, but like I can just read this. And then, so the key should be cube ingress based domain. And then variable should be this one. So your external IP nip and nip in nip.io. So here, and then so you can copy the external IP here. So and then like make sure like you can uncomment, you can unchecked protect variable and mask variable, and then add variable. You click add variable, and then you can get variables for now. Cool, and that's all we've done. Okay, cool. So I'm sorry about a lot of troubles, but like we will take a break now. So 10 minutes. Please return in 10 minutes.
Hey, Nanaka, just to make sure that we get it all done by 4 o'clock, we're actually going to make it only a 5-minute break. So
Okay, I'm sorry.
what we're going to do is we're going to come through at 3:15 Australian time. So 1/4 the hour. Awesome. All right, we are right at 3:15, so we're going to get started here again. Thanks, Tanaka, for that. That was, it's a very complex start of the Kubernetes part, right? This is the more complicated part of the workshop. Hopefully, a lot of you, and I saw some comments saying that they did get it working already. If you didn't, then the Instruct platform and the GitLab group will be available for 48 hours. So make sure that you keep these windows open so that you can return to it later on. Additionally, there will be a recording that comes out afterwards as well, so that you can review some of the content. Awesome. So there's another poll on the screen, and this one's really focused on AI. I know we haven't really touched on AI during this workshop, but potentially in the future we will be looking towards doing that. So this poll, right? Are you currently at your organization considering adopting AI practices into your DevSecOps workflows? And this is a pretty straightforward question, but yes, already started. Are you planning and exploring your options? Do you have no plans at the moment, but you're open to it down the line as the technology matures? Or are you in one of the rare cases, no and never will, very adverse to that AI encoding question? Awesome. So it looks like, the majority of you are starting to explore your options or are open to it down the line. It's a very interesting topic, this AI, and especially generative coding as a concept. Generative coding can, make the actual process of coding much more efficient, but you still have to have really solid DevSecOps foundations in order to be able to handle that much code and push out changes with velocity. So very interesting. I'm sure that we'll have an AI workshop sometime in the future, just to go over, many of the different capabilities that GitLab's introducing across the entire DevSecOps workflow. Awesome. So what you guys did over the last lab was install a GitLab agent and connect the agent to GitLab from a Kubernetes cluster. What we're going to go through now is how to use some of the GitLab functionality in order to make use of that, in order to deploy web-based applications. That's actually why we installed Ingress, is so that we can install a web-based application, and also how we manage some of the containers in GitLab. So back to our Tanuki Racing company, right? We have this agent up and running. We want to do a quick deployment test before we write the full end-to-end pipeline that's going to be very bespoke for our Tanuki Racing organization. And we want to take advantage of all the lessons that we've got so far. So one of the features of GitLab that we do know about is one called Auto DevOps. So this is going to use a lot of the features that we've done already, and as well build out some of these other templates and use some of those best practices so that you can take those into your own pipelines to get the same scans and jobs that are being run on that Auto DevOps pipeline. So Auto DevOps is effectively just another CI template. We enable this through a feature in the GitLab UI that allows you to set it as the default pipeline when there is no GitLab CI file within the project itself. It makes use of a lot of our other reusable pipeline templates. So all those ones that we were looking at earlier are included as part of the CI pipeline that is Auto DevOps, as well as a couple of others, especially around review environments, which is functional for the Kubernetes agent, and as well for things like EC2 or ECS. The Auto DevOps pipeline, right, it has an auto build, so language agnostic build. It runs the test stage, so that's going to be your application security scans and as well the unit tests. It deploys a review app, which is a pretty cool little ephemeral environment that allows us to do some peer review testing. And as well, it lets us do our dynamic application security testing as well. After we get through all of that, we go through maybe a staging environment if we wanted to do some QA or regression testing. Then we can go into production using this Auto DevOps template. And there's a couple of different rollout options there, right? Incremental, manual deploy, or even just full continuous performance testing. And as well, we run a quick browser performance test just so we can get some comparison metrics as part of that within GitLab. Awesome. So with that, we're going to jump right into Auto DevOps. We're going to go back into Instruct. I was following along with Nanaka. So my environment is all set up at the same point you guys are. You should be at the second last stage here, and this is where we're really going to implement some really cool DevOps. So the first thing that we want to do is start to open up our enable our project rather for auto DevOps. So the first thing we want to do is come back out to our workshop project. So make sure you're on that workshop project, and we're going to come down in the left-hand menu to settings. From settings, we're going to click on CI/CD, and that's going to take us to the CI/CD page. You may recognize this from when we set up the variables, but we're not going to set up a variable here. When we're in the project CI/CD, we can get a few more options like the auto DevOps pipeline. So we're going to turn on default to auto DevOps. When you click that, it should actually give you some options for the rollout strategy. For this, we're just going to use the continuous deployment to production, and we're going to make sure we hit the big blue button that says Save Changes. So now what we've got is we've got that auto DevOps pipeline, and that's going to be our pipeline configuration if we don't have a CI file present in the project itself. So we have this CI file. So, sorry, if I just go back quickly, one thing that we're going to do, just because it's not quite compatible with this project, is we're going to set a particular CI variable that's going to change how that auto DevOps works. So we're going to come back to settings CI/CD, and we're actually going to add another variable in here. So we can go into CI/CD variables, we expand that out, and we can click the big blue button that says add variable. And we want to add a variable called test_disabled. And we're just going to set that to true. Now, we want this to run on every branch, so we're going to unprotect it. We're not going to mask it because it's not a sensitive variable. And we're going to go ahead and add that variable in. So now that's just going to customize how the auto DevOps pipeline works a little bit. So now that we've got that variable in place, we can come back to the to our homepage, and we want to open up our web IDE again. So for me, it comes under edit. It might just be a big button that says web IDE for you. So you can come into your web IDE. And what we're going to do here is we're actually just going to rename our GitLab CI file so that it doesn't get run, so that we don't have a GitLab CI file. So in that file browser, we're going to right click, rename, and we're just going to call it hold.txt. And that's just so that we don't have that GitLab CI file, so that auto DevOps pipeline can then take over. So what we want to do now, right, at step 5 is come into the source control, and we want to commit that. So we can just click the commit to main button, and that's going to commit those changes up. Now we can go back to our project and check out the pipeline that's run. We actually can see it from here. We could go into the pipeline directly from here, right, by clicking on this circle, or we can come through build pipelines. And we can see that this pipeline is actually quite different, right? So we've had our pipelines that we created, right? They're just pretty basic pipelines, even the multi pipeline configuration that we had. But if we click on the auto DevOps pipeline, we can see that that there's a few more jobs here, right? So we've got a build job. It's not the same build job, but it's still a build job. We've got all of our different tests here. We've got a Dast environment deployment. So that's going to deploy a little ephemeral environment for us to run our dynamic application security testing against. Then it's going to deploy to production, run that browser performance, and then stop the review environments. So the reason that we put that ingress variable in there before is so that when we deploy these Dast environments and the production environments, that tells Kubernetes that through using this automatic deployment, we actually want to give that application an externally facing IP, so that the runner can communicate and run the Dast job against that IP, so that we can actually run the Dast job and access those production environments as well. So before you move on to the next step here, right, we want to make sure that the pipeline has entirely run. So we can come back and take a look here at the pipeline. Apparently it's taking some time for my build job to succeed here. And the reason that we're waiting for this is just so that we can check out some of the different features, right? Like, once it has deployed, it's going to fill out an environment as well. So under operate environments, once that pipeline has finished, we'll be able to see our different environments here, right? We don't have a deployment there yet, but we have defined that environment using the GitLab CI file as well. And we will be able to access the application through there later on. And the reason that we're waiting here, right, is that the next step that we do here, right, this step 2, is going to be looking at the container registry. So this auto build that GitLab publishes as part of the auto DevOps template, how it works is if there's a Docker file in your application code, it's going to build that Docker file. But if you don't have one, then it's going to detect the language that's being used by your project, and it's going to use a Heroku build pack to build a container even without the Docker file. So now that the build's completed, what the auto DevOps pipeline does, as well as just running that build, is it actually publishes that build into the GitLab container registry. So under deploy container registry, we can actually see that we've got that container, the container image published here. So this automatically does a lot of versioning and allows us to have a secure place to store that container on top of the just being built within the pipeline. So this is going to allow, again, right, more and more inner sourcing, more and more collaboration between various different teams, so that you can create standard images and then consume them in other projects. So with that, we have actually finished this stage of the workshop, and we can go on to the next one while that pipeline finishes up its deployment. Awesome. So while we're waiting for that, I'm just going to talk a little bit more about Auto DevOps. It takes quite a few different deployment options. So a lot of these can be configured using CI variables, as well as through that user interface that we were looking at. So one of those deployment options is the default, right? The one that we're doing now, which is going to automatically deploy to production without having any incremental rollouts, without having any staging environments. And we saw that through the pipeline. But as we mature as an organization, we might want to include certain different environments, like that staging environment. So when we have that staging environment, then we can automatically change the production jobs from being continuous deployment to being manual jobs. And that allows us to have that staging environment. We can go and do peer reviews and testing in a production-like environment, and then still have the freedom to go and deploy to production using the pipeline later on. One of the other options that we do have is incremental rollout. So this is going to be especially useful when you're using multiple nodes for the deployment. So for example, we had 4 nodes, replicating the project, and we only wanted to roll out to 10% of them. Okay, well, let's say we had 10 of those replications, and if we just wanted to roll out to 10, we could then have a manual job that rolls out to 10% of our production nodes, so that we still have the other 9 there and do that fully zero downtime deployment, managing the load balancing between those different pods. Additionally, right, 25%, 50%, as you would expect, that's going to roll out to 2 or 5, and then 100 is going to roll out to the entire cluster. So using this incremental deployment, it allows for some of these more advanced deployment use cases, such as things like canary deployments or blue-green deployments as we go through. So we just activated Auto DevOps through the user interface, but it is actually published as a CI template as well. So when you're in that CI editor, you can actually define a template that you want to use as the base, and that will automatically import that pipeline from the GitLab repository that's storing the pipeline templates, and just copy all of that into your own CI file within the project that you're editing for. How Auto DevOps works is it's actually a whole lot of other jobs that have been templated combined into one single pipeline template. So what you'll see if we go and look at the Auto DevOps source code is that it's actually made up of about 10 or 12 different CI templates, which include that auto build, the auto test, the auto code quality, auto deploy, as well as all of our different security scanners. Well, most of our different security scanners. So that's the static application security scanning, dependency scanning, secret detection, container scanning, license scanning, and dynamic application security testing. Now, all of those come together into the Auto DevOps template, but you can take any single piece of that, right? Just include that single template and create your own custom pipeline that still uses some of the components of this Auto DevOps, but then allows you to customize it further as you need for your different use case. We already had a look at the container registry that GitLab ships with, but GitLab also has a number of different package managers. So for specific package managers like Maven, NPM, PyPy, we do publish specific package managers for them. We do also publish a generic package manager, which allows you to store any kind of file. So I've seen that being used for things like machine learning models, or even just TXT files or release evidence, so that you can have a spot to store all of those compiled artifacts alongside your code, alongside the pipelines, alongside the merge requests, and really create sort of a single pane of glass centered around that project that stores all of the different artifacts relating to that project. Awesome. So what we're doing now is we're moving on to the very final part, which is going to be transferring the project. So what you can do if you're finished and ready for to take the code that you built during this workshop and move it into your own private namespace, you can follow along with this. But again, right, it is only done if you have completed all of the different workshops. So when you transfer this project, if the namespace that you are transferring it to doesn't have an ultimate license or doesn't have a Kubernetes cluster already integrated with it, you're actually going to lose some of the capabilities that are available in this project when you do that. So what I'll do is I will come back here and we'll just go through this this last step here, and we'll check the status of this pipeline quickly just to see if we can show the environment. So we can see that this pipeline is actually completed now as we've gone through some of that. So now, if we were to come into our operate menu, we can go to environments and we can see that that production environment has actually been deployed. Pretty cool. It's got all of the information about that, who triggered it, that's me in this case, the commit that's been triggered, when it was deployed, and even linking through to the individual CI/CD job. Because we've got this environment here and we know the IP, we can actually even open it up and take a look. So because we gave it an ingress but not a cert manager, it doesn't have a DNS certificate. However, we can just continue on because we know about this application. And hopefully my internet holds up long enough for this page to load. And we can see that we've actually gotten this application deployed and live on our Kubernetes cluster. And we can see some of the times people are posting on that Tanuki racing app. So what I'm going to do now is I'm going to come back to my source code. And again, only do this if you completed the remainder of the labs. But what we can do is take this project and move it into a personal namespace, right? Totally optional if you want to keep this work for your own reference later. So what we need to do first, right, is that we can't actually transfer that project while we have these containers in our registry. So the first thing we're going to do is we're going to come to the container registry and we're going to delete some of the all of these tags. So we can do that just by clicking on the delete button. Right, this one's called main, so we're just going to type main in there, and we're going to delete that using the big red button, and that's been scheduled for deletion. So it's going to take a couple of minutes to delete, but while it's doing that, we can just go on to the next step, and hopefully by the time we complete that step, it will have finished up. So we can just come to general and scroll down to advanced. And what we can do is, if we go to advanced, we want to locate the transfer project. There we are. It's just a little bit too short. I had a feeling I was in the right spot. But you can select this drop down and move it into any namespace that you want, right? So I'm going to move it into my personal namespace. And you can just select that namespace, search for it, or just select it from the menu and click transfer project. So once you transfer project, it will be no longer in this namespace that has this ultimate license, that has this Kubernetes cluster, and you won't be able to make use of some of those features unless you also have the relevant license and Kubernetes integration. So we can just click transfer project. This confirmation is going to pop up. We just have to copy and paste the name of the project in here, and we click on that confirm button. And hopefully, yep, so that has been moved successfully. If we look at the breadcrumbs up here, we can see that this is now in Rob Williams rather than GitLab Learn Labs. So now that that's all done, what we're going to do is we're going to move into the conclusion.
Thank you so much, Rob and Anaka. Thank you all for coming. Hopefully that you already got some little insights for today. I do want to go through a few little quick housekeepings before you all leave, so please stick around. First of all, thank you, Nanaka and Rob. Nanaka, I know it was your first time doing the workshop, so really appreciate it and great work. Before we all head off as well, I do want to let you know that this workshop will be sent to your email. So it will be the email that you've used to sign up to this event. There'll be recordings and slides. There'll also be a survey link, so within that email. So we do appreciate if you do fill that in. That will help us continuously improving our workshops. And in the future there as well. We do have an email that actually the moderator there has just posted. If you have any questions in regards to this event, feel free to flick it to that email. Or alternatively, you can add Rob, Nanaka, or myself on LinkedIn as well. We're more than happy to help out there. Lastly, we do have an event coming up, which I'm very excited to announce. It is our GitLab 16 launch event. So that is a virtual event that will be running tomorrow, and we've just got the link posted there as well. So for everyone around the APAC time zone, it is roughly 2 a.m. Our time. However, if you don't sleep like me, I'll be tuning in, so feel free to tune into that event. But you can also sign up to that, so you can receive the recordings as well. So I recommend, even if you can't attend that 2 a.m. session, feel free to put in your details so that you can have the recording once that is done. There will be lots of focus there and a lot of exciting updates, and the big focus there is where AI is heading within that DevSecOps space. So feel free to sign up to that event as well. That's it from me. Thank you all for coming. Stay warm, and we'll see you in the next event. Thanks, guys.